In this crash course, we're going to be talking a little bit about brick design. Bricks are becoming more popular here in New Zealand. They're very popular back home where I come from, Toronto. Lots of small family homes and also high-rise buildings get brick. There's different types. There's brick on a cavity, so a brick veneer, so one brick with a cavity behind it. There's also structural brick, multi-width brick, could be 2 layers of brick or 3 or even 4 with ties between them to make a structural wall. But today we're going to be talking more about the cavity cladding veneer brick design with a few other things as well. Now, when it comes to brick, there's a lot of benefits. They are very durable, they're very tough. People can kind of run into them or scuff themselves on it. It's not really going to hurt the cladding. They do not need to be painted, and if you install them unpainted, then they don't need to be painted for the rest of their life. And it's really minimal maintenance. Sometimes after, a few decades, you might have to repoint the mortar if you're starting to see it erode a bit, or if there's cracking, might have to replace some of the mortar, might have to replace a few bricks here and there to fix those cracks. But generally, it is very durable. So it's a very good choice for a building that you want to be durable long term. Now, with that durability, with those benefits, you also get some drawbacks. The drawbacks are that it is a very stiff, very rigid cladding, so on a very flexible kind of wobbly building, maybe brick is not the right choice. I would say it's best to use brick where you're using it for its strength, or not for its strength structurally, but just for its strengths, for its benefits, as opposed to trying to put it on a building that really doesn't want it there. As an example, if you have a 1 to 2 story square single family home, that's great for brick. Whereas if you have a tall, narrow building with lots of corners and ins and outs, and it's a very flexible building because it's super tall and super narrow, that's probably not the right building that you want to put a brick on, because you're just fighting against the natural tendencies of that brick. It is heavy, it is stiff, it is rigid, it is brittle, and so you're just really kind of fighting against it. Use it on a building that is, I guess, uses it for the strengths of the brick as opposed to trying to fight against it. Now, the first thing people mostly think about when it comes to brick design is the structure. How do we hold these bricks on the building? And the key thing for that is the weight. A brick is a heavy piece of material. It's a heavy type of cladding. And so what you have to do is you have to support these. You have to support the weight of them somehow. And what it typically is for a single family home, something shorter, 1 to 2 stories, is you're just stacking these on top of the footing, on top of the concrete slab, on top of a little step down or something like that. But it's right onto the ground, and then you're stacking all the bricks on top of it. When it comes to a mid-rise or high-rise building, you can't really do that. It's very, very, very poor practice to stack 5 stories of brick on top of one thing. It's just, that's not how the bricks want to move. It's a little bit too tall for, expansion and contraction and things like that, for movement, etc. You really don't want to do that. What typically happens for a mid-rise building, a high-rise building, or any scenario where you can't put the brick directly onto a footing is usually a shelf angle. And what that is just an equal angle piece of metal, thick, bolted into the side of the concrete slab, into the CLT slab, into the steel floor structure, into a steel beam somehow. But basically it's just an angle on the outside of the building, and then your bricks sit on top of that. That's the easy part. Just, support the weight of the brick. But then the next part is the brick ties. And that's not holding any weight. That's not what brick ties are for. They do not hold the weight of the brick. What they do is they prevent the brick from leaning inwards and outwards. It's called out of plane movement. And so you're trying to prevent that. What it does is it really just ties that brick back to the building so it doesn't fall out due to wind pressure, due to movement and things like that. Brick ties are fairly simple. Usually it's just in line with the timber studs, so usually 400 or 600 spacing, and then you're just choosing 400 or 600 spacing up and down. And what that does is you're putting a bunch of brick ties into the brick. Each brick tie holds a certain amount of area with all the mortar all together, and that's just a tried and true method, tested over time, trial and error. With the brick ties as well, you can have the typical strap ties, which is just one piece of metal drilled into the structure and then put into a mortar joint. But we also have these funky ones, and you can see them here. These ones have been tested. That's why they're all bent up. But you have a little angle like this. The angle gets screwed into your into your structure, and then this wire goes in. The wire gets embedded into the mortar, and then it also gives you side-to-side movement for seismic movement, and then up and down accommodation for construction tolerances and whatnot. And then we also have this longer one, which allows for some external insulation. So you put your external insulation in, your brick tie goes in like that, that goes into your mortar, and it holds it all together. So, like I said, brick ties are really just for out-of-plane movement and preventing that. Two-part brick ties allow some movement, which is what you want on a mid-rise, high-rise building. Usually, those buildings will be more flexible than a single-family house, and therefore, you want these bricks to kind of be compartmentalized into squares or rectangles that all move independently of each other with some movement accommodation between them. We'll get back into that, but one thing I'll mention is that with smaller homes, there's been a lot of testing from brands, shake tables and whatnot, where they were testing out single family homes with brick cladding, and what they found, based on the results, was that a lot of times the brick cladding, because it was using one-part brick ties, the strap ties, there was load transfer between the structure of the building, the timber, and the brick as well, so it kind of stiffened the whole building. And the unfortunate part is that we don't have any testing from brands for high-rise buildings, and that's when we know that that really doesn't apply once the movements go a little bit too much, or if they're competing with each other. With a high-rise building, you'll have inter-story movement, and so you'll have the stories moving back and forth with each other as opposed to the whole building moving as one. So either way, all that being said, when you're going to a mid-rise or a high-rise building and trying to use a brick cladding, you just have to think about the movement, and we'll get into that. So as I said, when you're going to a mid-rise or a high-rise, it's a little bit different than a smaller single-family home, and that's why the guides that you get for brick, like the off-the-shelf stuff, doesn't quite apply to those mid and high-rise buildings. There's just more movements and different movements that need to be accommodated for in those buildings. Now, how do you accommodate for those? Well, basically the general structure of or the general kind of assembly of putting together a brick, like I said, you have your shelf angle or you have your concrete ground, you put your bricks on top of those, and as you're putting a brick, you put mortar, brick, mortar, brick, mortar, brick, mortar. The mortar solidifies and glues itself to each of the bricks, and you can see it also goes into the little holes to make little frogs or little, I guess, dowels of mortar in there to hold it all together even better, give more surface area. But there are certain situations where you do not want that rigid attachment that you would get from a mortar connection. So things like corners. At the corner of a building, you should have a full vertical movement joint from top to bottom of the building. Smaller family homes, you'll have those corners laced together with each brick kind of stacking on top of itself that way. But for a high-rise building or mid-rise building, because you have a lot more movement, especially if it's a long, narrow building, at that corner, you want to allow the bricks to slip by each other without locking into each other and cracking. So if you've ever seen a bigger building that has cracking around that corner because of a brick, you'll know that it's because there was no movement joint installed there. So that's for like an external corner. That also applies to an internal corner. So if you have, an L-shaped building, that internal corner of the L, you also want to have a vertical joint there to allow that movement, because you'll have one part of the building moving in one direction, the other part moving in the other direction, and you want to allow them to slip by each other without cracking. Now, in addition to that, then you also want to think about controlling cracking around things like windows. So with a window, what you have is one large expanse of brick and maybe two windows in there. What happens is the whole brick panel wants to stay rigid, but because the windows are connected to the timber structure behind, sometimes they start to interact with each other and start to hit the bricks. Or without even having the windows interacting with the bricks at all, just that opening in the brick means that there's concentrations of stress at those corners of the windows. And so if you don't have a movement joint, or you haven't accommodated that movement, or you haven't put steel reinforcement into your mortar joints to stiffen everything and strengthen everything, then you could start getting diagonal cracking above windows. And that's fairly typical for older buildings. Now, to control that, like I said, you can put reinforcement into it, or you can just understand that there will be movement there will be concentrated stresses there, and you put a vertical joint, let's say at the side of a window, top to bottom, from floor joint to floor joint, shelf angle to shelf angle, and that allows each rectangle of brick to move independently without smashing bricks together or causing concentrated stresses which cause cracks, which kind of perpetuate outwards from a corner. So you can either stiffen it and reinforce it with inter-mortar ties, basically just metal wires that are in the mortar at those corners, or you can cut a movement joint, just, you know, a 10 mil, 15 mil sealant joint to go at that corner vertically. And then that'll make a nice tidy little line that won't crack over time. So you have to think about cracks, but instead of trying to make it as strong as possible, sometimes the easiest path of least resistance is just allowing the movement to happen without making damage with a sealant joint. Now, the other thing that I see pretty often on bricks is efflorescence. And efflorescence is that white kind of salty staining that you see on the outside of a brick. I see those on newer buildings, I see those on older buildings, and generally it is correlated with moisture in some way. So I've seen different versions. On a new build, what I've found is when the masons are putting the bricks up, sometimes they're not being very careful with the back side of the brick, the interior side, you know, inside the cavity. And so as they're spreading the mortar, bits and bobs of mortar are falling into that cavity. And if that happens, that could block your ventilation holes, that could block your drain holes, that could mean that there's, you know, additional water in the system, more water than those bricks are typically understood to be able to take without causing damage. So if that's not draining and drying very well, then you could have a lot of moisture in your bricks, which starts to pick up salts from the mortar, from maybe the brick, you know, residues and things like that. And what it does is water carries those salts to the outside of the brick, and then dries and solidifies, and that's when you start to see that white staining. So for new builds, what I've seen is as not only as the mortar falls back there, it's just left in place, but also I've heard that using a water blaster, a pressure washer in that cavity to try to spray out all of the excess mortar is one way that people do it. And that is a very bad idea, because you're just loading up your bricks with a whole bunch of water and allowing a lot of it to saturate and pull those salts out of the mortar. And then as it dries, the efflorescence starts to come out, because as the bricks get heated up by the sun, everything kind of gets baked out of it. So yeah, don't do that. First of all, keep your cavity as clean as possible. Be tidy while you're installing if you're a mason, but also do not ever water blast behind your bricks. There are a lot of guides that say do not do that. Listen to those guides, don't do that. Now, if you want an easy way to keep that cavity clear, there are things that you could import from different countries. These are from Canada. Had them on a couple of projects. And what these do is these sit at the bottom of your brick cavity. And as mortar falls on top, it might block this area, but this area stays open for drainage and drying, the sides of it. So these are castellated pieces of kind of expanded mesh foam, something like that. And what they do is they sit at the bottom of the cavity and allow the mortar to sit on top of them, bits and bobs of mortar, but still allow drainage and drying to happen. So a very easy, simple, you know, it costs money, obviously, it's an extra material, but maybe that saves time, which saves money on a project. So yeah, efflorescence is a big thing to worry about. Make sure you are watching the masons and that they're not overloading the bricks with a bunch of water, using the right mortar, not using water that might have some salt in it, etc., etc. It's just a quality control. Another thing you can do with bricks, but a lot of people believe it's not possible because they just haven't seen it before, is external insulation. You can externally insulate behind a brick. There are a few buildings already here in New Zealand that have been built, some of ours. It's a very simple thing to do with some off-the-shelf products from Canada, actually. This brick tie, as I mentioned before, allows for external insulation. This gets attached to the structure, insulation goes in there, the brick tie goes into the brick mortar joint, and Bob's your uncle, it's easy. You still have your cavity there, you have your insulation. But what do you do about the structure? How do you hold these bricks? How do you hold the weight of the bricks? Well, there's this fun little contraption, and what this is a bracket that gets attached to the outside of your slab edge, CLT slab, metal structure. It's got this diagonal slot so that you can adjust it up and down side to side, which is pretty cool. And then I don't have a shelf angle, but I have this piece of metal, which is kind of like an angle. What it does is it clips in there. And if this was, you know, a little bit straighter, it would fully seat into there and you'd have a shelf angle. And what it does is it just holds onto the building like that. So the insulation would go in this line right here, and then you still have your cavity behind your bricks, which are sitting on top of this angle. So there are ways to do it. It's quite simple. It might even simplify and make the install easier, because sometimes the shelf angles, getting them straight is difficult. But if you have these brackets, it gives you that adjustment. So maybe that's something that you do. So external insulation can definitely do that with brick. You just have to think about it and use some different tools and techniques. Other things that we do typically see with brick is corbelling, which is stacking the bricks so that the face of them is slightly out or slightly in. Perfectly easy to do. I think generally up to a third of the depth of the brick. If you corbel it, it's fine. Anything above that, you have to start doing actual proper design to make sure that it's going to work. The other thing that we see a lot more often, and I'm not sure why there's this craze, but brick screens. Brick veneers that have holes in them with windows behind them and things like that. Very, very, very popular these days. I think they are a much more difficult and labor-intensive thing to install in New Zealand because of the seismic movement that we have here. I don't think they're worth it. I think there are other things you could do that would provide the exact same visual, aesthetic kind of nicety that you would get from a brick screen, but much, much easier to install and design. Because with a brick screen, if it's a tiny little one in a very stiff building, that's probably easy. But if it is any sort of, you know, regular movement building and it's a large expanse of brick screen, there's so many forces seismically just with acceleration and weight and momentum, that you're putting a lot of extra structure into that just to make it work. You can make it work, but it's just a lot of extra structure just to make this one thing work. So I kind of recommend, if you're in New Zealand in a seismic area, probably just go with something else. Metal screens work very well. There are other ways that you can simulate a brick screen without using bricks. All that being said, there's some other accessories that you can go with bricks. There's like little vents that go into the bricks. That is a very important part of brick design, and avoiding efflorescence is having adequate ventilation. So at each shelf angle, wherever you're stopping and starting your brick, you want to have vents at the vertical slots of each brick. I can't show you on this because there's only 2 bricks here, but at the vertical slots, you have vents to allow airflow through the entire system into the cavity and out of the cavity to dry things out. All that being said, I think that's a pretty good basis for how to design brick. If you ever need any brick design, let us know. We are very good at it. We have done it on a lot of buildings, and we can help you out, make it simple and make it beautiful.